Okay, in this video, I'll be going through question 14. Question 14, it is basically a question on kinematics, and I have included some questions on forces into this as well. For some reason, when you see this line, 20 Hertz, some of you thought that you can use V equals to F lambda to solve some of the question, but V equals to F lambda, it is a very specific formula only for wave, light, sound, things like that. And in this case, it is basically a hole puncher. There's no wavelength for you to apply this formula to. So some of you are having some difficulty interpreting this long question. So first, actually when I set this question, I also expect students find it challenging. That's why I give this diagram over here. So what does a frequency of 20 Hertz means? So for example, how it works is that there is this puncher that will lower the pin down, right? The puncher down. So in order for you to make a hole on the puncher, obviously the puncher need to go down and punch the hole, right? Then after that, the puncher will get lifted out, correct or not? And as this piece of paper is being pulled along, at a new position, let's say at a new position, the puncher is going to lower down again, right? So every time the puncher lower down, that it will make a hole in the tape, correct or not? So what is frequency? Frequency means the time taken for one oscillation, right? So what is one oscillation? So this is one oscillation, what? From this point, go to the high position, then go back low, correct or not? So actually what it means is that 20 Hertz, if you take 20 Hertz and you change it to a period, it will be 1/20 seconds, right? So what is the time taken for the puncher to move away from its initial position, which is the down position? Then after that, from down position, the puncher is going to be lifted up and then go back down. This is one period. So actually the time taken for the puncher to make two holes is actually 1/20 seconds. And this is how you solve part 1. The time taken to complete one oscillation and punch two holes. So actually when I make this question, I try to give you a hinting word. And actually when we check the paper between the physics teacher, we also have a small debate on whether or not to give you this, and we finally decided, okay, we will give you some help. So since we already give you the time taken to complete one oscillation, the time taken to complete one oscillation, isn't it this? And you have to make T the subject, and you get this. So you will get this, and then this will give you 2SF. Yeah, so actually the time taken for the puncher to make two holes, we need to put the puncher down first. This will make the first hole, and then the puncher will get lifted up and then back down. This is one oscillation, and so the time taken is one period. Simple as that. Okay, for part 2, it is kind of tricky because very seldom you see this word estimate. So what do I mean by estimate? So down here, you need to understand the context first. So first, the car is at this position, X. And then the car is attached to one of the end of the tape. So as this car is traveling towards the right, it will pull along the tape, right? And as the tape is being pulled along, the holes will be made ta 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 ta. So in figure 14.2, you will see the complete tape. So basically, this is the part where it is attached to the car, and then it is pulled along this way. So down here, this part, right, is the initial part, right? Then after that, as it is being pulled along, this refers to a later timing. So as you observe, right, down here, the gap between the hole are actually getting further and further. This means that my car, right, is speeding up. Because the time taken to punch two holes is fixed, it is your 0.05 seconds, right? The fact that the next hole appears further away, meaning that my car is actually speeding up, right? So that's how you interpret your ticker tape. So to summarize on what I have go through so far, this yellow part of the tape represent an earlier time, so initial. This green part of the tape is what happened later. So now I need to find acceleration, and we all know that acceleration is given by final velocity minus initial over a period of time, right? Now using this information here, I know the distance, and of course I know the time, because for the car to make this bit of journey, the distance, it takes 0.05 seconds. And to travel this, it is another 0.05 seconds. So from here, actually I can find out my initial velocity, which is 0.4 divided by 0.1 second. So far, so good. Now at the green part, this happens at a later time, right? So from here, I can actually find my final velocity, which is 0.6 divided by 0.1, because again, I have one gap, two gap. So far, so good. So if you calculate this will give you 6 meters per second. This will give you 4 meters per second. So now my formula here would be 6 minus 4 over t. Now I still cannot solve this because I do not know the t. So how does the word estimate come from? So now if you look at this velocity, actually this velocity is not an instantaneous velocity, right? It is an average speed. Total distance divided by total time. And I can only say that by estimation, this 6 meters per second will give you the best estimation as the instantaneous speed when the car makes this stop. When the car is traveling at this position, because this is the average, right? And similarly, I can say the same for this. So at this center dot, this will be my V, and this will be my U. So how much time is taken to change the velocity from U to V? Well, that duration is given by 1 gap, 2 gap, 3 gap, and I almost forgot 4 gap. Correct or not? So now with this, I will be able to tell that my duration here is 4 gap. Each gap will take 0.05. And with this, I will be able to find that my acceleration is equals to 10 meters per second square. So that's how you do it for your part 2. Now moving on, the question becomes a kinematic question, which is being adapted from your 2020 paper 1. And when we are going through paper 1, a lot of you say that I understand already, yeah, very easy. But when we check your understanding at a deeper level, we find that there is a major misconception. A lot of you think that the driving force comes from the engine, and then you write driving force here. So are you saying that you can have a car with no wheels, just the engine running, and then the car will move forward? No, right? The engine in the car, what happens is that you will have an engine in the car that turns something, And then using some gear, this thing will turn a shaft, and this shaft is attached to your wheel of the car, right? Correct or not? And when the wheel turns, it basically brings your car forward. And that is because when your wheel turns, the friction generated is actually forward. So, actually, when the question says that only the front wheel is driven by the motor, so when the front wheel is driven by the motor, it is spinning this way, and yes, it will generate a friction forward. And this friction is responsible for driving the car. So in this particular context, you can call this friction the driving force as well. And because the motor is only linked to the front wheel, the back wheel is just dragging along. So as a result, there will be only the frictional force this way. So in essence, to answer this question, the front wheel is where your driving force is acting on, and then the back wheel is friction. Now, because during the go-through, after speaking to the physics teacher, we didn't make this very clear in our lesson. So for this round, we will accept driving force, or if you write here friction, we will accept. Okay, we'll give you the full credit. Okay, but please, from now on, you should know that actually that particular friction over here is actually the force responsible for driving the car. Similarly, if you are walking or running, okay, let me draw the feet. Okay, if you are running, okay, wear some pants. Okay, if you are running, your leg is, you are trying to swing your leg this way, right? So when you are running, yes, the friction is forward, and this friction is also responsible for driving your body forward. So if you would like to call this the forward force, you can do that. But what you shouldn't do is that you shouldn't take the free body diagram and say that there is driving force plus friction here. No, they are the same force, you just call it by a different name. Okay? So that's one. That is how you solve B part 1. For B part 2, like I said many times, whenever you are analyzing the question and you see non-SI unit like that, you need to be on high alert. So my habit, like I shared with you in previous video, is that I will always put a star to remind myself that, hey, I need to change unit. So for this case, if you look at the free body diagram, there are only two forces here, friction and driving force. You notice that I didn't draw the weight and I didn't draw the normal contact force. Because when you are applying your Newton's second law and all those, you can only solve it in one dimension, either the horizontal or the vertical. So in this case, the question says that it is having a mass of 600 grams, which is equals to 0.600 kg. Okay, at this point of time, I still have students who couldn't do the conversion correctly. And you also will tell that the average frictional force acting on it is 0.25. So this one is your 0.25. Okay, some of you are arguing and say that, hey, but you say the driving force can also be known as frictional force. Does it mean that the driving force is 0.25? No. You need to be exam smart about this, because if it is 0.25, then there won't be any acceleration. Then you may ask, teacher, but I don't know what if there is indeed zero acceleration? Then if it is zero acceleration, then this ticker tape diagram would have equal interval. So that's why this toy car is accelerating. So you know that there is acceleration, and hence you should know that the 0.25 refers to friction at the back. Okay, so once you have this done, down here you are also told that you should assume that the acceleration is what you found in part 2, which is 10 meters per second square. So once you have this, basically it is quite straightforward. Apply your Newton's second law, change the left hand side to the definition. Remind yourself that all this you are talking about the horizontal forces, which will have D plus negative F, because sum of forces, and MA. You need to know that your D and A has to be the same signage, because you know that the car is accelerating in this direction. Yeah. So once you have that, it is a matter of correct substitution. Remember that your mass has to be converted in kg. So this, then you got A, you also know, is 10. And then you have your D minus 0.25. So if you do your math correctly, you should have 6.3 Newton corrected to 2 SF. Okay, moving on. For part C, I mix the topic a little bit and it becomes a DC moto question. So for DC moto question, I have some very good answers regarding part I. But before that, I just want to take the chance to clarify with you that for DC moto, the force acting on the wire is there. Okay, maybe not at this position. Okay, this position maybe you can argue that there's no force, or you want to argue that there is force. So actually in your C part I, right, you can approach this question in two ways. The first way is that you assume that there is still current flowing through the wire coil, and as a result you will have two forces acting on it. You may ask me, how do I know it's up and down? Well, the magnetic field is this way, and your current is, in this case, it is coming out of the paper. So if you position your Fleming's left hand rule properly, you will be able to see that the F is like that. So if you belong to the first group of students, you believe that there is still current flowing through the wire coil, then what you can see is that at this particular position, there is no moment, even though there is a force. And that is because if you draw the line of action actually cuts the pivot, and that will give you a zero perpendicular distance. So if you want to do approach A, you will then need to be very clear, okay, that the moment, remember whenever you say moment, you must tell me is about which reference point. So about the axis, it's 0. Then, because I gave you 3 answer lines, you need to provide more detail. For example, why the moment is 0. So in this case, you can say something, you need to be able to describe the perpendicular D. Some of you just give me this. No, this is what you do in the notes. So you need to describe it. So you have to say that because the perpendicular distance and whenever you mention distance, you must tell me is between what and what. And if you are unable to do that, you won't get any marks for this case. Okay, so since I am taking the moment about the axis, then this perpendicular distance will be about the will be between the axis, and this one is the keyword that many of you forgotten. It's not the force, it is the line of action of the force acting on the wire coil. Done. Okay, so this is approach A. There is another approach, because if you look at this, okay, actually there is still contact between the carbon brush and the split ring commutator. Okay, but because current will always want to flow the least resistant path, which is your shortest path lah. You don't want, the current would not want to go through the entire wire coil, right? So you can also argue that at this position, the carbon brush are connected to both pieces of split ring commutator, and as a result, the current will not flow through the coil. Okay, some of you are telling me that it is not in contact, but if you look at the diagram, I have paid close attention to all the diagram that I draw, and I purposely draw it such that it is in contact. Okay, some of you may be asking me, then what will happen? Okay, maybe I take this opportunity to answer that. So this is the carbon brush. It's like a toilet brush. It's a brush, right? Then I will have another brush. Right, then this connects to the rest of the circuit. This is the brush on one side. So if you have, wrong. So now you have something like this. Can visualize? Yeah, so you have something like that. So what will happen? This thing, this thing, right, is connected then to the rest of the coil, and then coil, this one come back, right? Then this coil come back, and then this thing attached to here. Okay. So how will the current go? Well, the current will go like that. Then from here, the current got two choices, right? Go here or go here. Then after that, the current will go here. Then current got two choices, either go here or go here. Then finally come back to here. Then, there's two choices. Then after that, come back to here. Now I want you to focus on this choice. When the current comes to here, it has a choice, right? Either to go to the coil or to go across, right? And we know that in parallel connection, the current would always choose the least resistant path, or most of the current will go to the least resistant path. And resistance depends on the length of the wire. So obviously, the coil is a longer wire, right? And just going across, it is much shorter. Not to mention that the cross-sectional area here is also huge. So definitely going across like that will be the least resistant path, and most of the current will decide to go there. So as a result, I allow you to argue that the current that goes into the coil will be very small until that there's no force. Okay, so I allowed that. Okay, but technically I think approach A would be much safer because the line of action is cutting the axis. So definitely no parallel D. Okay, let's move on to your part 2. For part 2, I have a lot of, okay, I won't say a lot. I have a portion of candidate trying to explain that the split ring commutator will reverse the current and all that. Please note that the question didn't ask you why does the rotation going in a singular direction. They didn't ask you that. Okay, instead they are asking you, hey, how come it can turn past even though part I says that there's no force or there's no moment. So for part 2, what I'm looking out for is your understanding of your inertial. So you have to tell me that since the coil is already moving, or in this case spinning, the inertial, that means the reluctance of it to stop, in this case, to be specific. The inertial of the coil will allow it to continue spinning even though there is no moment at the vertical position. Okay, so you need to learn how to interpret the question and understand what is the subject matter there. Okay, so there are a lot of questions on DC circuit and you need to know that exactly which part is responsible for what. So for those of you who answer that, oh, the split ring commutator will reverse the current, and then as the current reverse, the forces acting on the wire will reverse. That is to answer why the rotation is only in one direction. Okay, which is not what the question is asking here. Okay, finally we reached the last part. So for part D, most of you are giving me wonderful answer. There are some of you who still refuse to pay attention to the details or try to memorize the words that the keywords that we use. So I hope by going through this question again, it will shed some light and convince you to use our explanation. So there are a few basic error, common understanding, I would say, that you all have. Number one is that evaporation is spontaneous. What does spontaneous means? Spontaneous means that evaporation doesn't require energy gain or energy loss. It just happens. So what does it mean? It means that even if you have a cup of water which is cooler, let's say 20 degrees C, in an environment that is like 40 degrees C, evaporation will happen. If you have a cup of water that's 20 degrees C in an environment that is 10 degrees C, evaporation will also happen. Now, why do I give you these two examples? In the first example, the water is gaining heat, right? So evaporation happened, okay, fine. In the second example, the water is losing heat, but evaporation will still happen. That is what we mean by spontaneous. And I can give you the third scenario. What if they are at the same temperature? Well, evaporation still happens. So in all three cases, evaporation happens. It is spontaneous. It just happened, right? And if the question wants to ask you, can you explain to me why it just happened? Then you need to go back to kinetic model of matter and say that, oh, due to random collision, some molecule will just gain enough energy to get out of the liquid surface. But very seldom they ask that, okay? So that's number one. And what is that? How would that affect the way we answer the question when evaporation is spontaneous? Well, in some of your answer, you all will say something like, oh, as the liquid gain heat, then your evaporation happens. This is wrong. This is wrong. The liquid do not need to gain heat in order for evaporation to happen. Just now in the example I have already shared with you, the evaporation can happen even if the liquid is losing heat. Yeah? So I hope you understand this and remember that in your explanation about evaporation, you should never write things like it gains heat, it gains energy. No, it doesn't. They don't gain anything. It is spontaneous. Okay, error number two. Error number two is you all feel that, let's say the engine, this is the engine. And I have a layer of lubricant on it. And you say that the lubricant gain heat from engine. Well, in order for the lubricant to gain heat from engine, they must be of different temperature, right? There can only be heat transfer when there's a difference in temperature. But in this case, if the engine is, let's say, 80 degrees C, the fact that the lubricant is on it will tell you that the lubricant is also at 80 degrees C. So the lubricant will not have a net heat gain from engine to lubricant. They started off at the same temperature. Because it is a very thin layer, it is on it, they will have thermal equilibrium very, very quickly. So you shouldn't say that there is heat gain from engine to lubricant. It just doesn't work, okay? And this common mistake has been seen in many of your answers, and it is really disappointing to many of us teachers, because we give you notes, we give you all these things, but you are not reading to the detail. You are still imagining things your way. Okay, so we hope that this prelim paper did knock some sense into you and alert you to all these details. The third thing that I want to point out is that you must point out that your evaporation, it is a surface phenomenon. It only happened at the surface. So many of you all remember that, oh, okay, I need to talk about energetic particles or energetic molecule. Can you please add in the word that this energetic lubricant molecule is at the surface? Okay, please, please, please highlight this. And I have some of you who tell me that there's water molecule. There's no water molecule, it's lubrication molecule. Yeah, inside a lubricant there's no water. Okay, all liquid can evaporate, not just water. So can you please move away from water, 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 water? Yeah, it can be just lubricant. Okay, so in your answer, I hope to see the energetic lubricant molecule at the surface will leave. Yeah, let me get this away. Will leave the lubricant surface during evaporation. So with just one sentence, you have highlighted that it involved the energetic particles, the molecules at the surface, leaving the surface during evaporation, right? So what will happen when the more energetic one leave the water surface? Well, what happens is that the average internal kinetic energy of the lubricant, notice that I didn't use lubricant molecule, I say lubricant because I have used the word internal over here. So there is no molecule. Okay, don't use the word molecule. There's nothing more internal when you bring it to the molecular level. So the average internal kinetic energy of the lubricant will drop. And we all know that the average internal kinetic energy relates to the temperature. So as a result, the temperature of lubricant will drop. So far what we have covered is that at the beginning, my engine, I shouldn't draw 3D, very hard to continue. My engine, and then I have lubricant on it. They are of the same temperature, right? Then my energetic molecule leave. So the IKE here would drop. And when my IKE drop, the temperature here will drop. When the temperature drops, then there is now a temperature difference, and that will result in the heat loss, right? So down here, the temperature drop, so hence there will be heat transfer from engine to lubricant, and that is how you set up your cooling effect. Alright, so that is the end of your question 14, which consists of kinematics, or I should say interpreting a diagram, applying your kinematics,